we started integration by inspection. We did apply write down all the rules of integration. So if let's say we try and look into functions where we need to try and apply U method or U substitution. So I'll still start with algebraic functions. So maybe if I take maybe one example here, let's say we have 1 over 2x plus 1 to the power of 5. Let's say we have dx. So what I'm going to do is that I'll always, remember what I can tell you, please always have an eye of inspection. Inspection is very key. We're going to try and do inspection, maybe we might have derivated to get the following function. So, but here we don't have really a quotient, we have a constant in the numerator. The function in the bracket is in the denominator. So if it's just one function, you can try and maybe take 1 to the numerator, these functions, and try and figure out fully. So if we have 2x plus 1, and I have it all in all to the power of -5, dx. The idea why I took the whole bracket to the numerator, we thought of the rule that we applied yesterday of chains of functions, that we inspect what is in the bracket and what is multiplied by the bracket. So if we have a derivative of this function inside the bracket, and which is true, we do have the derivative of that, because derivative of this we're supposed to get a constant, but we are missing that 2 there, because derivative of 2x plus 1 is supposed to be 2. So we are missing 2 there. So which means if we're going to add 1, we're going to divide by that exponent and divide by the missing factor. So, but as we said, we want to try and use u-substitution, but already we know the answer by inspection. So what we're going to do, we're just going to say, we want to let now the function inside the bracket. Normally we let the whole function inside the bracket to be equals to u. So 2x plus 1, we want to let it to be equals to u. From there, we're going to derivate both right-hand side and left-hand side in terms of x. So derivative of the right-hand side in terms of x, we have 2, therefore which is equals to. So derivative of u in terms of x is what? It is du over dx in terms of x. So that's how we do. So as I was saying, we have let the function inside the bracket to be equals to u. We don't just let any function to be equals to u. So you have to inspect what is the function, what we might have derivated to get maybe the following derivative we're having here. So as we said, by inspection, I saw that this was the power bracket rule there, or chains of functions. But in the meantime, when we say we are letting u the function equals to u, we want to replace dx, we want to replace x, or the function which is in terms of x there. So in the meantime, we need to make dx subject of the formula here. So if we make dx subject of the formula, it multiplies on both sides, and we divide by 2. So we'll have du divided by 2. Now the second part, we are going to replace now in original derivative there and substitute. So we said that 2x plus 1 is equals to 2x plus 1, we said is equals to, in the summary, we said 2x plus 1 is equals to u. It's equals to u. So all in all to the power of -5. Okay, I was copying from top there, I'm substituting. So we said it's u to the power of what? Now multiply by dx. So what is dx? Dx is, so it is du over 2, or half times du. From there we can integrate in terms of u. We can integrate in terms of u. So you're allowed to factor out the constant, which is 1 over 2. Just factoring out 1 and the denominator, which is 2. So which is 1 over 2. So I want to show you that we have to integrate in terms of u. So I hope you see that this calls in for power rule because we know that this now is in algebraic form. So when we integrate in terms of u, we know we are using power rule. So we're having our half there. So it will be u to the power of, we add 1. So we must add 1. We add 1. So minus 5 plus 1, -4. So we need to divide by -4. Remember, we're not subtracting, we are integrating, we are adding. Let me just do that. Therefore, plus constant when we have integrated. I hope it's clear. So when we integrate this formula, I said look into this. You ask yourself, what did I derivate in terms of u to get u to the power of -4? We were subtracting, we were multiplying and subtracting. So now we are adding and 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 and, and dividing. So simplifying full, this is a negative exponent. I'll have 1 over. This will be negative. This times that will have 8. U will be to the power of 4. Therefore, plus the constant. So we are not done. We need to replace back the variable that we said we are replacing in terms of x. So which is going to be equals to, we'll have 1 over -8. Then all in all, we have 2x plus 1 to the power of 4 plus the constant. So therefore, that is our integral of function 1 over 2x plus 1 to the power of 5.